And really, there's no reason why I can't
Coming in?
make them do.
Want the same questions, Andrew?
Well, that's what I'm trying to think. There's really not a reason why I can't do the same thing if we have different people, because
Sure.
the people that did plants last year, like, want to do plants again this year. So I mean, I'm changing it. Like, I'll have to change what we do, but for the most part, like, I mean, they can decide next year, I guess, what they want to do too. We could do that. Yeah, we could do the same question. We'll do the same question, and we'll see how they respond.
There are other classes where all the levels are actually the same. It's just the students don't see each other, so it doesn't really matter.
Gotcha. Well, I don't want to bore anybody. That's like at the top of my list of things not to do. So.
I am
You wanna
never
see
bored
something-
when there's a bird in the background tweeting, and I just really like.
Could you hear that?
Yeah, I really like it.
If you want to see something really embarrassing, I have to take over my sister's room to my parents' house. She was a big Sailor Moon fan when she used to live here. So this room is full of Sailor Moon memorabilia.
Nice.
Is one of the reasons why I don't use video all the time, because people can be like, what kind of stuff?
Brad's really into Sailor Moon.
I mean, if
Wow.
it was like Dragon Ball Z stuff, I'd be all about it. But Sailor Moon wasn't my thing.
You
I'm
guys
not
know
convinced that this is your sister's room.
Yes, sister's room.
Uh-huh.
Yeah.
Do you guys know that we have like this like crazy like anime comic shop place like here in Pittsburgh, and it's like right on Broadway, and it's
Yeah, is it? I can't remember what it's called, but I've seen it.
and it's like only open like weird hours sometimes, and
Yeah.
like you can't tell like that it's actually there unless you literally are looking for it. Like it's almost like hidden. It's kind of interesting.
Isn't it just full of like old restaurant tables for people like go in and play Magic and stuff?
I think that's a different one. We
It's a
actually have
different one,
like
okay.
we have like 3 comic book shops in Pittsburgh.
Yeah.
If you guys don't know, there's like one that's called like the Ogre's Lair. That's more of like crazy. Like you can buy everything from like a reproduction like battle sword to like comics to like old movies to all kinds of crazy stuff. And then there's one that's like the game shop or game something or other that's downtown, and it's like literally magic and comic books.
That's what
And
I
then
was thinking of. I
there's
think.
another one that's like literally like anime, like it's all just like was it manga and stuff like that. So it's like crazy.
College towns are the best.
I really haven't been spending much time on any of them in any of those places really. So cool. All right, so there should be a poll that's out there for you, and it says, what sounds cool? Do you guys want to do space? Do you want to talk about plants, or do you want to talk about earthquakes? Man, I am like, really, that's so interesting. Maybe people just had bad experiences with earthquakes in the past, and you're like, my favorite class in college, one of my favorite classes in college, one of them was the space class, and the other one was earthquakes and natural disasters. And the earthquakes and natural disasters instructor had a thing where if you legit took the test and answered all of the questions throughout the entire semester and you got zeros on all of them, he would give you an A in the class. But if you got one question right, welcome to your 1% for the entire semester. So it was like you had to know the information well enough to know exactly what not to put on the exams. He was like, he's only had like 5 people take him up on it. And he had like 3 of those people actually succeeded. The other 2 ended up getting like a couple of questions wrong on the final or something like that. And by wrong, I mean right. And so they were screwed.
Oh, no.
So anyway, but it was pretty cool. He had theme music. Every time he come into the classroom, there'd be theme music on. It was pretty sweet. So, well, I think it's probably safe to say that they can join up later if they want to join with us today. But hi, everybody. So my name is Andrew Willett. It looks nothing like what it's spelled. And I'm going to be your instructor for this summertime. And we're going to be talking about space, which is going to be pretty sweet. So I like space a lot. I've actually got a group at the college called Astro Cats. And it's kind of like the Panthers, like, you know, like we're the Astro Cats. And we kind of do some space stuff, and I kind of got hooked up with one of the reps for the International Space Station associated with their educational group. So we've got some opportunities to do some fun stuff with some data from the actual International Space Station. So it's going to be kind of cool. We can also do some fun things along the lines of like maybe what kind of things are you interested about space? So maybe that would be the next question on this. So let me go ahead and open up the chat so I can kind of see. And then it says, Adrian wants everybody to go ahead and put their names in the chat box. So that way we can kind of record attendance. But then at the same time, while that's going on, why don't you guys think about, do you think you could maybe give me just maybe just a couple of things that you're interested in about space? And then we can kind of go from there. So that way it kind of gives me an idea of what to plan out for the upcoming weeks. So that way I can kind of tune into like what you're interested in. Because these upward bound classes, especially during the summertime, it's a lot of fun because usually during the semester, I have to cover so many outcomes and we have to hit so many things. And a lot of times we have to kind of make sure that everybody has the basics before we get to explore any kind of like interesting subjects. So with the upward bound class over the summertime, it's almost like the opposite. Like I can start with the really interesting subjects and then we can kind of fill in and put in the necessary stuff to kind of make sure that we kind of strengthen those goals that we're going for overall. So, you know, what are you interested about space? You know, I like space a lot. I had a couple of uncles that used to work for NASA. And so I've got a lot of, I've actually got here, hold on. While you guys are thinking about what you want for space, let me grab these real quick. I'll show you something really cool.
The drawback to the webcam on a Chromebook is if you have the Chromebook sitting in your lap and opened to an angle where you can see the screen comfortably, you miss the entirety of your face with the camera at Sailor.
That's not fair. We can see the top of her pretty hair and
That's
the
true, yes.
painting on the wall.
Yeah.
Yep. Yep.
I painted that painting like 3 years ago, and I've just never removed it.
I love it.
So is there anything about space that interests anyone in particular?
I would like to learn about light years and how to measure with them.
Ooh, cool.
Good. I like that answer.
That is a good one. Black holes, yeah.
My cat's doing that thing at the door where he wants in, so he thinks if he just like digs the door enough, I'll open it. Nope.
It might work eventually. He's just got to keep trying.
It usually does work to his credit.
Okay, let me see here. So I've got this right here is actually my uncle, and he used to work for NASA, and he would do stuff with satellite communication systems. And so he spent some time down in Florida, and then he was spending a lot of time in Ohio when he was at the Lewis Research Center. And I am actually the keeper of all of his stuff right now because he passed away a couple years ago. And so what we have is we have a lot of the pins from all the different years, like the tie tacks of like when he was like working for NASA. They got like his different 5-year, 10-year, 20-year, 30-year, 50-year. And then he's got all kinds of like stickers and patches. And like I've got a flag that was flown up in space, that went up in space and came back down. I've got one of those around somewhere. I can't find it right now, but just from helping with the mission and stuff like that. So I've got some cool space memorabilia, and I like space a lot. I'm really interested in stuff like astrobiology, where we kind of try to answer the questions of like, where did we come from? And is there life like outside of this planet? And if so, is it like us or is it different, you know? And so we got some cool things that we can kind of do as far as that, and I got to hook up with the instructor at the International Space Station. So we should be able to get some data and do some fun things because there's lots of stuff that we can actually do with this. Now, what do we got over here? It looks like we got black holes, other dimensions. Oh yeah, like the white fountains, like the idea of like a black hole erupting into like a white fountain and stuff like that. We can do all kinds of neat things like that. Nukes in space. Yes. We have nuked space before, and I believe that that's actually where we got some of our radiation belts. We actually have some human-made radiation belts around the planet right now that are associated with our nuclear activities in space. And then Mars, that's a good one. That's on everybody's hit list as the next stop for a lot of things. And then measures put into space for humans to survive in space, the ramifications of space junk. That's all pretty cool because there's definitely a lot of that going on right now. How long does space continue for? Ooh, let's get into like some warp drive stuff, craziness. Okay, so looks like I got a lot of cool suggestions for us to work with. So that's great. Okay, we can definitely do this. How many of you guys have seen the movie The Martian? Have you guys ever checked that out before? Has everybody in the class seen that? If not, let me know. I don't want to ruin anything for you, but I think we can kind of come up with we can grab some of that. We can maybe look at some of the tech that they have, and we can also kind of explore some aspects with that. Oh, it's pretty good. If you haven't seen The Martian, you should check it out. It's got a pretty good cast, and it's pretty cool. Oh, Picard or Kirk? I didn't even know that was an answer or a question. So, But anyway,
It's not. It's a trick question.
Is that new Kirk or old Kirk?
Oh, I should say Kirk or Picard or Kirk then.
Ooh, that's rough. So no, it's not. It's Picard. Jeez, everybody. God.
I know,
so
it's
anyway,
obvious.
But we'll go through. We got some fun stuff we can definitely do for that. So, well, good. All right. Well, then we can definitely be working on space. So what we're going to be doing is I've actually got some virtual labs that are set up, and it's not going to be the same every week because this first week I didn't really know what you guys were going to pick and what you wanted. So I've got some pretty generic stuff set up for this first week. But after this first week, everything's going to start being a little bit more customized. So this is to give you an introduction and to kind of work on some of the skills that you got tested for on the pre-test. So the pre-test covered 3 different sections, and you got about 3 questions. Here, let me take these off. It's a little bit distracting. So you got about 3 sections, and you had about 3 questions from each section. And at the end of the semester, what I'm going to do is I'm going to give you basically one of those tests. You're going to get like a prolonged period. So you're going to get a section test, in addition to the test that you already took. And a lot of that stuff focused on working with graphs and working with numbers. And that's also what we're going to be kind of incorporating throughout the course of the semester. The content of those graphs and of those numbers and everything like that can be where the fun is. What we can look at various different types of things. But I've got a space lab that's set up at the very beginning for this first week for you to try and kind of get your feet wet a little bit when it comes to this idea of doing virtual work. So let me go ahead and I'll show you that document. Let me go ahead and do screen share. And let me pull over this one. And actually, let me stop this and let me share my computer sound and optimize the screen share for video clip. So that way it helps it out a little bit more. All right. So I'm going to come into my drive. And then let's go to the Stars and Galaxy Virtual Lab. So I'm going to put this in your guys' class homepage. So we are not in Science 3. We are going to be in Science 2, right? So
Correct.
Science 2. Let me go here. And then let me go up to classwork. I'm gonna see if I can remember how to do this. It's gonna be a little clunky this first class period, but we're gonna get it smoothed out here. So I'm gonna go to assignment. We'll name this Stars. Let's just say Stars Virtual Lab. And then complete table and answer questions. And let me go ahead and add, let's make a due date of next Friday. Don't worry about the time, and then we'll give it a topic. So we'll do week 1 homework. Make it worth 10,000 points, and
Yes.
add file. This one there. So make a copy for each student. There you go.
Yes.
All right, and I'm going to assign this for you. So now if you access the home page, you should see the STARS virtual lab should be there for you. And if I come back here to the stream, you should see that I posted a new assignment in there. So if you click on this, you now should be able to, well, oops, I don't want you to see this. But if you click on this, it should take you there and you should be able to grab a copy of your sheet that I just put up there. So what I'm gonna do now is I'm gonna go ahead and go to my sheet. So this is what you should see. Now this is a Google Sheet that I've kind of put together for you already. It has a links to the virtual lab here. And so what I'm gonna do is I'm gonna click on that. And then Adrian, if you could do me a favor again, and could you post that video?
I'd be happy to.
That would be great. So notice how, let me see if my computer does it. Yep. Let me see if I can't stop it right there. No, I can't do it. What you will likely run into, especially if you don't already have this enabled in your computer, is that these virtual labs, especially for this first week that I've got, run off of something called Flash. Now, to get Flash to run, it's kind of had some vulnerabilities and people are kind of phasing it out. And so you have to actually allow or give your browser permission to run Flash for it to be able to work. So if you don't have Adobe Flash, you're gonna have to install that. But most of you guys, if you're working on Chromebooks, it should be already part of the browser and you're just gonna have to enable it. So it's gonna look like a little puzzle piece. And if I load this up right now, you should see there's a little puzzle piece there. And then it actually says control, it says actually to click on that to allow for Flash to run. A lot of times too, what you'll find up here is up in this section of your address bar, there's gonna be basically a warning that says Flash was blocked. And you'll see like a puzzle piece. If you click on that little warning, it should take you to your settings within the browser and you should have the option to enable Flash. Now, if you do that, what it should do is every time after that, it's gonna ask you if you wanna allow Flash to run. So then you can click on it and say, yes, allow Flash to run, and then it should bring up what you're seeing right now. And I believe Adrian's put a link in the chat that should help you kind of like walk through that. So there should be like basically like a video walkthrough. Yes, how to install Adobe Flash Player on your Chromebook. So it should work that way. And really this is the last chance. You guys are probably gonna be some of the last students to do these because in December of this year, Flash goes away. Nobody's gonna really support it anymore. So take this opportunity to use this and get in on some of this cool stuff. Now this lab is actually something that is really kind of neat. And it's so like, I can't even like explain to you like how like mind-blowing some of this stuff is, okay? So in this class, right, for this lab, what we're gonna be doing is we're gonna be looking at the spectra or the light that's coming off of some of these some of these stars. So this is what the virtual lab will look like. And what we're gonna be doing is we're gonna be selecting, we've got star A, B, C, D, and E, and you're gonna work your way through all the stars. When we click on star A, what we're gonna see is we have this spectra that pops up. And what's really like crazy about this is, right? So if you go outside and you just look up at the stars, they just look like a whole bunch of like twinkling lights, right? And they don't necessarily like look that different from everything else that's up there. Like they're all roughly about the same. Some are brighter, some are, you know, darker, some they little shimmery, little, you know, And a lot of that effect is kind of just part of the atmosphere of the planet. But then also, you know, you're getting hit with photons in your eyes from something that's like billions of miles away. Billions of miles for the photon to come and then hit your eye, and then it's done, right? That's how crazy it is. And for that photon, it's just a fraction of its life. It exists, and then it hits your eye, and then it's absorbed. And so when we actually look at those dots up in the sky, we actually find that there's hidden information that's encoded in the light that's coming from them. And that's what this spectra is. So do you see all these little lines that are here? These are spectral lines where we have basically emission at certain wavelengths, at certain parts of the light that's coming from a star. So when we point the telescope at a star, we can actually isolate a certain area around a single star, and we can record the light coming only from that star. And when we do that, we can actually collect the spectral data that's here. Now, what's really neat is that this tells us what the star is made of. So take, for example, we have all these lines here. These are emission lines. If I come here and I look at what calcium looks like, this is what calcium looks like. So when we look at emissions of calcium, we've got this here. So I want to pull this over, and you can actually use this as a tool to help you gauge what the star is actually made out of. So for this one, for star A, do you think calcium is present in the star? It looks like it is, because these lines look like they match up here. Now, not all of them will necessarily match up. But what's really neat is that sometimes the stars are combined spectra, so they'll have calcium and they'll have other things. Do you think helium is present in this star? I'm not really seeing it, right? I've got this very clear red line here, and I'm not seeing anything up there. I've got, you know, no matching up here. But let's see, what about hydrogen? Ah, here we go. If I pull this over here, do we have a match? Yep. And I have a match here, here, and here. So far, this star has got calcium in it because it matches up. And then also we have hydrogen. And then you can come down here and say mercury. I'm not really seeing a whole bunch that match up to mercury. And then I'm also looking at sodium. I don't really see a whole bunch of sodium that matches up. Those aren't really the same. So far, this star A has got calcium and it's got hydrogen in it. So what I can do then is I can go back over here and I can say, all right, elements present. Well, star A, I know I've got calcium. So what I'll do is I'll go ahead and I'll bold that. I'll do Control B. Oh, does that even work? I thought it would work. Maybe if I do it this way. What? Do I have to do it like this? I don't know. For some reason, the shortcut's not working. And then also hydrogen. So what I'm going to do is I'm going to come through here. I'm going to highlight, and I'll make that bold. And if I want to really put some emphasis, maybe I'll make it italicized too. So I've got those elements that are present. I can come back to my stars and galaxy thing. And I can say here, brightness is moderate. So then I can come back to my thing and I could say moderate. And then temperature, I can get the information here, approximately 6,200 K. Does anybody know what K stands for? Does anybody know? We've got a couple of people. Brad would like to share. What do you think it stands for, Brad?
Kelvin.
Oh, try again. Has anybody else got the answer? Do you know what that stands for? No, he's actually right. It's Kelvin.
I was like, wait, I'm a double down on that.
So there's lots of different ways that we can look at temperature, right? So we've got Celsius, which you're probably not very familiar with. That's usually the rest of the world, right? So American. So anyways, we got Celsius. We don't really use that very much unless you're in science, okay? So Celsius for a lot of science and other countries. And then we have Fahrenheit is usually the one that you're most familiar with. So take, for example, how those two are related. Water will freeze at 32 degrees Fahrenheit. That's equivalent to 0 degrees Celsius. So 0 degrees Celsius is freezing, and then 32 degrees Fahrenheit, that's freezing. So there's a difference there when we start looking at the temperatures. Now, Kelvin is a temperature scale, which is kind of like what we consider to be absolute. So we can actually, Kelvin kind of refers to like when molecules are actually moving. So if we get down to 0 Kelvin, that means that the molecules have lost so much energy in a sense that they're not moving. And so we have this concept of absolute zero. And so Kelvin is what we usually use as our temperature scale when we're dealing with like planets in the solar system and stuff like that. And so we've got Celsius, Fahrenheit, and Kelvin. And so the temperature that we're recording today is 6,200 Kelvin. If you wanted to look that up to see what that would be equal to in Fahrenheit or Celsius, that would be kind of interesting as well. And so then we've got the spectral class letter. So we can go back over here and we can then basically, this is the spectral class. So once you've figured out what the elements are, you can basically grab this. Well, actually, if you click on this, yes, and sometimes the sound effects are really loud, so sorry about that, guys. But you can kind of go through and you can look to see what type of star it is. So it's got 6,200 K, so that means that it's going to fall in this. So it's type F. Dark lines, moderately strong for calcium and hydrogen, among other materials. That's kind of cool. All right, so 6,200 makes it about F, so we can come back over here to the stars and galaxy, and we can put in F. And then the HR diagram location. I'll let you read a little bit about that over here. And so this is some background information on the lab, but really the HR diagram, I think we're going to be talking about its location on this side, like left, right, that type of thing. And let's see, star color. Let's go back over here. All right, so this gives you the spectrum here. So we got Roy G. Biv. And really what you're going to do is you're going to grab A, and if I bring it down here and I try to stick it in this place, I'm going to check it.
Check the element spectra to determine the spectral class of this star. Then try placing it in the HR diagram again.
I think what it's trying to tell you is wah, wah, wah. So it doesn't go there, okay? Now, does that make sense when we look at this diagram? If we put the star there, right, we have increasing, oh, weird. So if I come over here, increasing brightness, maybe that matches up a little bit, but is our star at almost 20,000 K? Not really. Our star should be around 62 K. So we need to move it down this way. Not here, because that means that's corresponding to 10. Not here, because that corresponds to 6. So really, I think we need to be about there. And let's check it again.
Check the element spectra to determine the spectral class of this star. Then try placing it in the HR diagram again.
Oh, nothing like getting shafted when you're trying to give a demonstration. So I think actually maybe this one is correct. Ah, there we go. And so now it's filled it in. And so we can hit reset if we want to, if we needed to get more information about that, but it resets the star. But now we can move on to our second star and we can kind of analyze and go through this stuff. So what you're doing is you're working through this information here and filling out like star color, HR diagram location. I'll let you come up with your own classification for this. And then you're going to be filling in this information for A, B, C, D, and E. Now, why do we care about this? Why do we care about this stuff? Why are we looking at these spectral lines, and why do we care what the star is actually made out of? I'll tell you why. Because what the star is made out of determines how old it is. It gives us an idea to the approximate age of the star. So all the stars in the galaxy pretty much start off as basically big clouds of hydrogen that are going to condense on each other. And under the weight of gravity, we have this nuclear process that begins, which then emits light. And then what it's going to be doing is forming the elements. Have you guys ever heard of the saying that you are stardust? Have you ever heard of this before? We can't make our own elements on this planet very easily. We can't take lead and copper and then make them into gold. We can't really do that. We have to basically dig them out of the ground as they are and then melt them and use them for our various different applications. But in the heart of a star, under the extreme pressure, in the extreme heat, you actually create new elements. You actually get things to fuse together. And that gives that reaction from that, the release of the energy when that process takes place, gives the star its brightness, but then it also makes up these elements. Now, what happens to a star as it gets older? What's going to happen? You guys know we only got, and I hate to say this, we only got maybe another for 3 billion years on Earth. We got about 3 billion years to get off of this planet. And actually, it's way less than that. We've actually only got about 200,000 years left. And really, it's less than that. We've only got about 100,000 years. Well, I'm going to take that back actually a little bit further. We've got about 50,000 years on this planet before the conditions get to a point that life is no longer supported as we know it. Maybe microbes will be able to make it for another 100,000 years, but humans, we got about 50,000 years left. That's it. And then the planet will have changed so much because the sun is actually getting bigger. So the sun is actually getting bigger, which will affect our climate in a lot of different ways. So 50,000 years. You might say, oh my gosh, what are we going to do? I want you to think back about how much we've changed in the last 100 years. You guys ever talk to your grandma and grandpa? And do they ever tell you stories about how they had to like warm water up for their baths? Have you ever heard stories like that? Have you ever heard those, like the old people stories where they're literally like, cell phones? What's a cell phone? You know, like we had to mail letters when it was, you know, and there you go. Thanks, Zoe. You know, like we had to ring up on the telephone, you know, like, hi, Susan, you know, like from the Andy Griffith show, like I need to get a hold of so-and-so, you know, like, so, and now we walk around with a computer that's 10 times as powerful as the one that got the original people to the moon in the first place in our pockets. And we're connected to the internet in a short period of time. So 50,000 years doesn't sound like much, but it is a lot of time for us to get some stuff figured out. So we got about 50,000 years before the sun makes life it's not going to happen. And then the sun is actually going to get so big that it's going to suck the earth up. So if you thought maybe, you know, the earth's going to be around for a little bit, yeah, according to science, right? If we just take it just from a scientific perspective, the earth is going to get sucked up by the sun sometime in the future. And then it's going to basically, the sun's going to collapse. And then it's going to go boom. And it's going to supernova. It's going to blow out all the stuff into the area around it. Well, then what happens to that stuff? It condenses and it forms planets. And then ultimately, what goes on? Hopefully we have life that forms. So when you have this saying that we are star dust, a lot of the material that makes up your body, the carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, is actually formed in the heart of a star over millions and billions of years ago that went supernova, that then condensed into planets that ultimately becomes you. And so you are star dust. And then if you want to get even trippier than that, this is the even trippier part of this whole conversation. The elements that make up those elements, the quarks, the up quark, down quark, all the different subatomic particles that they talk about, those were in existence just a fraction of the second after the Big Bang occurred. And that is actually what's holding together a lot of the stuff that's also then made up of you. So not only are you part of the heart of a star, but in some sense, part of you has been around since the Big Bang. That's how far back we can go. That's the extent of our knowledge right now. So the stuff, the material, like literally the bonds that hold the atoms together, that make up your hands and make up your body, those have all been around for a long, 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 long time. And so some piece of you was basically present at the Big Bang, and some piece of you was present in the heart of a star. So no pressure to do something with your life after hearing me talk about this stuff, okay? So, but that's all right, because I know that you're all doing the best that you can. But so I love talking about space. I love getting the galaxy stuff. I love taking a look at like, what does that all mean? You know, and you got some big questions and some fun stuff. So that means that we can literally look up in the night sky. We can take just a sliver of light coming from a star, and we can calculate how old it is. We can know what the elements are that are inside the star that are currently present in there to the best of our ability, how far away it is, and we can tell how old it is. So just from looking at the light from a star, we can tell all of that information. And that kind of gives us an idea or an interesting, you know, an opening into like physics. And people don't necessarily like physics because they think that it's nothing but a whole bunch of mass. But in reality, physics talks a lot about the fundamentalness of existence, like, you know, stars, energy, what information can we pull, and then what information can we predict. The ultimate goal of physics is to be able to tell the future from understanding the past. And people don't really realize that. And if you go into physics, it'd take you about 6 to 9 years to get your PhD, but they'll pay you about $23,000 a year just to be in school. So that's kind of cool too. So if you like math, you like physics, you like all that stuff, you know, astronomy, all that's pretty cool. So anyway, it's by far my favorite science. Heck yeah, I like physics too. So geology rocks, nice. So, you know, and then that's the other thing too, is that we can actually look at some of the rocks that come from interstellar space. I've got a couple of lists that I keep. One of them is how many astronauts I've met. And the second one is how many space rocks I've touched. So I've touched about 3 space rocks. Whenever I hear that there's an opportunity coming up for space rocks, I'll go touch a space rock. You know, and so I've got about 3 of those that I've touched. And then I've met, I think I'm up to 4 astronauts. So I love space, love all the stuff about it. And maybe I can do something where we could get somebody to, maybe we could get part of like a Twitter feed, or not a Twitter feed, but maybe we could invite like a guest or something like that. Maybe we could do something fun. No promises on that because I haven't looked into it yet, but let me see what I can do. Maybe we can get like an astrobiologist to talk to us, or we could do something fun. So this is the virtual lab for today, for this week. And then what you're going to be doing is you're going to be answering these questions as well. So these are the questions. So what is the brightness, temperature, and the spectral class letter for the sun? So then I want us to know a little bit about our sun. You know, like what is this information here? And then I want you to do a little bit of research on your own, and I want you to Google what is meant by this idea of the Goldilocks zone. What do we mean when we talk about the Goldilocks zone? And that's in reference to help you out, just to give you a little bit of a breakdown on that. It's kind of involves planets, and then it talks a little bit about special properties of where we need to find planets that are kind of like Earth. And then it says, would you say it's possible? So that's obviously a misspelling there. Would you say it's possible that all stars have a Goldilocks zone? Why or why not? So I want you to think about that. After you've done a little bit of research on what is the Goldilocks zone and kind of give me an answer on that, I want you to take that idea, and I want you to think about the lab that we're doing. And then I want you to say like, well, then does that mean that there's a Goldilocks region for every star that's out there? Or are there some stars that are just incapable of having a Goldilocks region? And so then that kind of then leads us into these next areas of exploration where we're kind of be taken forward on this. So I'm going to take what you have as far as like what you're interested in, and I'll be making some labs coming up that are kind of related to that. And we'll see if we can't get some more information. I'm going to see if I can't pull some data from, they have the International Space Station that's always taking pictures. We can actually put in some requests for images that they're getting ready to do their next round, where they're taking pictures of different parts of the planet. And they've got different things, different activities that we can actually kind of like participate in. So I'll see what data I can be pulling for that. And then we can be exploring some of these topics. Now that I know what you guys are kind of interested in, we can kind of go from there. So it should be a lot of fun. And, you know, I'm pretty passionate about the whole space stuff. I like it a lot. I got the club at the college called the Astro Cats, and we kind of focus in on space tech and everything like that. So, you know, and lots of exciting stuff constantly happening in space. You guys, if you haven't watched the latest launch of the SpaceX getting the astronauts up into space, that was pretty sweet. So now we got some fun stuff that's going on with that. So I think that probably does it for today. I'm gonna let you guys get out of here just a little bit early, but make sure that you get into the classroom on the Google Classrooms and select which one you want to do. Not actually select which one you want to do. You've already done that. Go ahead and start working on your virtual lab. And then I think, was it last time, John, if anybody's having trouble, or if they want to hang around and talk about trying to get the Flash player enabled on their computer right now, we can kind of help you with that. We can try to troubleshoot you. Other than that, I'm going to go ahead and release you guys to go work on your stuff. And then I'll take what you got, and then keep your eye on the feed for the class, because I'll probably be putting some updated information in there before we get to Friday next week. I'll probably try to dump some in at the beginning of next week, like Monday, Tuesday, for you guys to kind of maybe check out and read up on. So thank you so much, everybody. It says, yeah, it's been working Instagram chat. Cool. I'm happy to meet you all, and it's going to be a fun summer. We're going to talk about some cool stuff, and hopefully we'll get to introduce you to some neat new concepts that you've never had before, and we'll have some fun along the way. So thanks, everybody.